So we've discussed some of the challenges that all animals face as far as survival and reproduction and their goal to maximize their fitness. And so they have a variety of ways of acquiring, getting food and digesting food and getting rid of nitrogenous waste and regulating their temperatures. So we've talked a lot about anatomy and physiology, and recently we talked a lot about the behavioral variation that exists in animals. The next topic is going to review what is called life history variation. So life history variation includes the timing and the degree of energy that animals will invest in development, maturation, body maintenance, and reproduction. And these are typically tied to the lifespan potential of different animals. Some animals have the potential to live a long period of time. Other animals may only live a few weeks or a year. And so this is going to change their life history strategies. So for example, this is a species of bird that we have here in the summertime. This is called the orchard oriole. And males that are 2 years old and older have this kind of burnt orange and black patterning. First year males that have not completely matured have this very different, distinct coloration. So life history variation addresses the question, why do they show this delayed maturation? So here's some other patterns of life history variation. Spadefoot toads live in the desert, and they reproduce when the rare rain comes up and fills up a puddle of water that is pretty ephemeral. So it's going to dry up pretty quickly, and they develop from tadpole to a mature adult within just a few days. So really rapid development. On the other hand, a big bullfrog can spend years in the tadpole phase, and they can do this because they live in permanent bodies of water like ponds and lakes. So another life history variation question that you could ask why there's this variation. Why do some birds lay a single egg per nesting attempt and may only nest once per year? And then organisms like oysters can produce hundreds of thousands of eggs in a reproductive event. There are going to be trade-offs for both of these strategies. In the case of the oyster, they can produce more individuals, but there's a very small probability that each of these individual eggs is going to survive because it doesn't have a very good start. It doesn't have a lot of yolk provided to it. A lot of them are going to be eaten by predators. In the case of the white tern here, this single offspring really requires lots and lots of care. And this individual probably couldn't put in the effort to raise more than this one individual. So by concentrating this parental care into this one individual, it increases the chance of it achieving fitness. If it tried to produce more, it just wouldn't succeed. Here's another life history trait that varies, and it's lifespan itself. So an adult mayfly can live only for a day, while some clams can live for over 500 years. And this is really one of the driving factors that leads to some of the variation in other life history traits. So if we look at maturation, reproduction, and lifespan, we see that there is a lot of variation among animal lineages. We've already talked about development, and all animals show relatively rapid initial growth during this developmental period, and then they show one of two basic patterns. So in the case of indeterminate growth, these animals will continue at a slower pace, but they'll continue to grow after reaching sexual maturity. And so the more years that they're around, the larger they grow as individuals, or as a colony, like in the case of a coral reef, or sponges. Sponges show indeterminate growth, and older sponges get larger and larger every year. Snakes also show indeterminate growth. Determinate growth is a pattern where once you reach sexual maturity, most of the body regions cease growth, and individuals maintain the same basic size until their death. So most insects do this, most birds, most mammals, so this is a very common pattern. So one of the common life history patterns that we see is there's a trade-off between survivorship and reproductive effort. And so we're going to see two basic patterns associated with reproductive potential and reproductive effort at any given time. So an Iteroparous species is a species that reproduces multiple times in its life, because it tends to have a potential for a long life. So birds, mammals, most fish would fit this category. And see, the trade-off is if an individual that has the potential for a long lifespan, if they try to breed too early in life, or they try to expend too much energy in, say, a single reproductive effort, well, that could be too costly, and it could result in an earlier death or reduced quality of future reproductive events. And so it's kind of a strategy in which you don't want to put too much effort too early. You want to kind of spread that effort out. Now, in contrast, a simiparous species is one that just reproduces one time in life, and it really puts everything into that one reproductive effort. This is due to the fact that they really didn't have much of a potential for a longer lifespan, so they put everything into that one reproductive effort, but it pretty much seals the fate on them surviving much longer after reproduction. Most insects would fit this category because, especially in temperate zone regions, they just don't live long enough to make it through, say, a winter period, and so they put everything into a short reproductive season. Salmon, while they do live for a long time, they spend most of their life growing in size so that they can be reproductively successful, and then they just mate and reproduce that one time before dying. So they're putting everything into it. So again, the driving factor for this, though, is that most of these species face relatively high predation threats or unlikely for a variety of reasons to live very long. And so they need to mature as quickly as they can and reproduce at a maximum rate while they can, despite the fact that it really does pretty much seal their fate about dying sooner. So I've been talking a lot about survivorship. And in life history studies, we tend to see three basic survivorship patterns. A type 1 pattern is shown by the dotted line here on the top. In this situation, so on the y-axis, we're looking at the percentage of organisms that are surviving from an initial time frame. So we start with what we call a single cohort. And then we're seeing as time progresses, maybe years, days, months, it could be any time frame. But as time progresses, certain individuals in these cohorts are dying off. Now, in the situation of a type 1 survivorship pattern, most of the individuals survive a pretty good long time, and you really don't see a high probability of death until you reach a pretty old age. That's the typical type 1 survivorship pattern. And that may sound familiar because that's basically what we do. It tends to be associated with relatively slow maturation, right? We're not sexually mature until we, technically get into our teens. That's associated with delayed reproduction. And we tend to produce relatively few offspring at any given time and tend to spread those out. Because otherwise, again, too concentrated of an effort could put this high survivorship throughout most of your life in danger and cause an early death. So this fits a pattern of reproduction that we would refer to as iteroparous. If you try to do too much too early maturation, or too concentrated reproductive effort too early, again, it puts your lifespan in jeopardy, and it could shorten your lifespan. So that typically isn't going to be worth it. An organism that shows a type 2 survivorship pattern has relatively moderate everything, moderate maturation rates and moderate and relatively constant survivorship curve. So every increment of time, it has about the same probability of surviving and dying, and so we see this steady decline of members in the cohort. Most songbirds fit this category, and so they mature, after about a year, and then they tend to lay a clutch of eggs for one nest or maybe two a year for a number of years. And so again, this would fit a pattern of being iteroparous. On the opposite end of type 1 is type 3, where we have really high mortality rates early in life, but if you make it through those critical period, it kind of tapers off so that a few individuals can live for a longer period of time. But because the bulk of the individuals are not going to live very long, they better mature as quickly as they can and produce as many offspring as they can. So this fits a more simulparous type of reproductive pattern. And this really is the most common survivorship pattern seen in the animal kingdom. So it includes the flatworms, snails, sea urchins, insects, frogs. If this is your survivorship probability, you don't have a shot of living very long, you can't waste your time. You got to mature quickly and you need to reproduce at the maximum possible rate because you're not guaranteed to live very long. If you want to maximize your fitness, you better get to it. Now there is another, those are the three basic survivorship patterns, but there is another pattern that's seen, and it's associated with temperature. Colder environments tend to produce organisms that have slow growth, they mature very slowly, and they tend to have a longer lifespan. So the Greenland shark, for example, is a classic example of this. These individuals grow very, very slowly. They live in very cold waters, and they can live up to 400 to 500 years old. So in review, we talked about life history traits and how they're tied to lifespan variation. So know the difference between indeterminate versus determinate growth, heteroparous versus simulparous reproductive patterns, and the basic survivorship patterns 1 through 3, and also how colder environments tend to promote slower growth and longer lifespans and delayed maturation. So life history traits are really tied to trying to figure out the best way to maximize your reproduction, and reproduction is going to be the topic of the next video.